in this equation, we want to calculate the value of n. So here we have 4 to the power of n plus 3 to the power of n equals to 91. Here, I'm going to multiply the numerator, the power by 3 times 1 over 3, which still shows you have 4 over n, because 3 times 1 over 3 is going to cancel out the same thing here. So now, recall this rule of indices, that a to the power of m to n is the same thing as a to the power of m times n. So I'm going to move the 1 over 3 in. So here I'm going to have 4 to the power of n over 3. That is n multiplying the 1 over 3, and we still have the 3 outside, plus 3 to the power of n over 3. And we have the power of 3 outside, which is going to be 91. Now let's x to be equals to 4 to the power of n over 3. And let y to be equals to 3 to the power of n over 3. So the given equation above is going to be x to the power of 3 plus y to the power of 3 equals to 91. Now from here, we have x to the power of 3 plus y to the power of 3 equals to 91. Now I'm going to give some conditions here. In this case, we have that both x and y, are positive integers, because while we're having 91 here and we are having the power to the power of 3, so each x and y should be positive integers, and that means our x is greater than 0, y is also greater than 0. So we have this condition intact. Now here we have sk plus yk, which is the same thing as saying x plus y, x squared minus xy plus y squared equals to 91. These are equivalent. These two equations are equivalent. Now we have this condition. Here we are having 91. So the factors of 91, possibly we can have 1 times 91. We have 91 times 1. Also we have 7 times 13, and here we have 13 times 7. These are the possible multiples of 91. Now let's consider this case. Here we have x plus y. Here we have x squared minus xy plus y squared. If we have 1 times 91, this is case number 1. Is it going to work? If you look at this, x is positive, which is greater than 0, and also y is greater than 0. So there's no way x plus y will give 1. This is not possible. X plus y can never be equals to 1. So case number 1 does not work. And looking at case number 2, if x is 7, and x plus y is 7, and this shows that what? X squared minus xy plus y squared gives 13. If you look at this case, we have that this is less than this. This equation is less than this equation. But let's think about it. If this case is valid, then we can consider this case. Let's know that. And let's look at number 3, case number 3, if we can consider case number 3. Since we have that x plus y is less than this, which is very obvious, so it is not possible that this is going to give us 1. So this third expression does not work, because why? This first expression is less than the second expression. And the same thing here, part D does not work. You can plug in to confirm, but the 3 other cases does not work. So we only have one valid case, which is 7 times 13. Now, recall that we have x plus y. And also we have x squared plus minus xy plus y squared equals to 13, equals to 7 times 13. So 91 has been splitted as 7 times 13. So from here, it's obvious that x plus y equals to 7, and also s squared minus xy plus y squared equals to 13. This is going to be my equation 1. This is going to be my equation 2. Now we have these two good equations. How can we get the value of x and y? Rewriting equation, let's rewrite equation 1. Okay, so equation 1, we have x plus y equals to 7. Square both sides, which is still valid expression. So equation 1 can be transformed to s squared plus y squared plus 2xy equals to 49. I'm going to call that equation 3. Now, we have two good equations we want to compare. The first one is the equation 2, which is s squared minus xy plus y squared equals to 13. And also my equation 3, which is s squared minus 2xy plus y squared equals to 49. Now, how do we go about this? Subtract. Let's subtract these two equations. So x squared is going to cancel out. Y squared is going to cancel out. So here we have x. This should be positive. Yeah. So here we have negative xy. Negative times positive is going to be negative. So here we have negative 3xy equals to negative 36. So dividing both sides by negative 3, we have xy to be equals to 12. Now we have xy to be equals to 12. I'm going to call that equation 4. The next slide, we have xy equals to 12, which is my equation 4. Recall from my equation 1, I have that x plus y equals to 7, right? So now I want to plug in. Here we can write this y equals to 7 minus x. Okay, so here, let me call this also equation 5. From equation 4, xy equals to 12. So y is going to be 7 minus x, which is equals to 12. So I just plug in the value of y in equation 4. So factorizing this here going to be 7x minus x squared equals to 12. Rewriting the equation here, you can have x squared, okay, minus 7x plus 12 equals to 0. This is a quadratic equation. Okay, now so simplifying this quadratic equation here, our two factors is going to be 3 and 4, which is negative 3, negative 4 is going to be negative 7. Negative 3 times negative 4 is going to be positive 12. So here we have x squared minus 3x minus 4x plus 12 equals to 0. Factorize x into parentheses, x minus 3 minus 4, x minus 3. So these two equations are equivalent. Okay, now x minus 3 is common to both sides. Factor it out. And here we have x minus 4 equals to 0. So here I can say that my x minus 3 equals to 0, and also my x minus 4 equals to 0. So here we have x equals to 3, and also we have x equals to 4. So these are the two values for x. Let me rewrite this. X equals to 3, and also x equals to 4. Recall that here we have from equation 5. Okay, recall from equation 5, we have y to be equals to 7 minus x. So here my y, let me call this x1, x2. Okay, so my y1 is going to be 7 minus 3. So y1 is going to be 4. So here my y2 is going to be 7 minus x as usual. Y2 is going to be 7 minus 4. And my y2 is going to be 3. So here we have x1, y1 to be equals to, when x is 3, y is 4. And x2, y2, that is when x is 4, y is 3. So these are the two cases that I have. Okay, I have two cases. Now, I want you to recall also from the question that up there in case 1, I stated that 4 to the power of n over 3 equals to x. Okay, 4 to the power of n over 3 equals to x. Here we have, and also stated that 3 to the power of n over 3 equals to y. For case 1, that is when x is 3. So 4 to the power of n over 3 equals to 3. And here we have 3n over 3 equals to 4. If you look at the base, they have different bases. So since we have different bases, this cannot work. So because this cannot be simplified further. So in the next slide, we have case number 2. That is, we have x2, y2. And my x2, y2 is 4, 3. Okay, so here we have 4 to the power of n over 3 equals to x, which is the condition given, and 3 to the power of n over 3 equals to y. So 4 to the power of n over 3 equals to 4 to the power of 1. If you simplify further, we have n over 3 equals to 1. Therefore, n equals to 3 in this case by cross multiplying. The same thing here, 3 to the power of n over 3 equals to 3. Here we have n over 3 to be equals to 1 and n equals to 3. Okay, so you can verify from the problem we have 4 to the power of n plus 3 to the power of n equals to 91. So if you have 4 to the power of 3 plus 3 to the power of 3, this is going to be 64 plus 27, which is 91. Thank you very much for watching. Please don't forget to subscribe to my channel, share this video, and also I would like your constructive criticism to this video to improve my teaching pattern. Thank you.